I said that in today's session, my name is Thomas Henuru, and the details about me is down there in terms of what I am working on currently. And today we are going to look at the methodology of assessing wetland using Earth observation data. But in yesterday's session, my colleague talked a lot about the stakeholders. And today we are going to see how important stakeholders are as far as analysis or assessment of wetland is concerned. So wetlands, like many other ecosystems, are being affected by many pressures, and these pressures are basically due to the activities that the day-to-day people around and also those who come from a distance do around and within the wetlands, and also due to the aspects of climate change. Now, this is a talk that most people are seeing, and it's happening all over, that climate change is affecting the different aspects of the environment as well as the human lives. And wetland vulnerability refers to, it's basically a relationship. It's a relationship between exposure to a particular risk or event, the impact of that event on the wetland, and the ability of the wetland to cope with the impact or the efforts needed to minimize the impact. So as we see that there is that aspect of the wetland having the ability to cope itself, but also the effort that external activities are being done to help it recover from the exposure or the risks that it has undergone. So the concept of exposure, sensitivity, impact, and adaptive capacity are included as part of the vulnerability. And they are especially important in the context of changes in ecological character of a wetland, for example, due to climate change. Now, you'll find that this term is being used interchangeably between the different spheres of studies, as well as different people use the language differently between vulnerability and degradation. So you'll find that sometimes people are talking about wetland degradation, and then today we are talking a lot about the vulnerability. So degradation basically looks at the aftermath of the effect of the exposure, and vulnerability basically tries to look at it before maybe the effect has detrimentally affected the wetland. So for example, we shall see in a later stage that there are different factors that talk about or that are referred to what makes a wetland vulnerable. And these factors basically tries to look at the current status quo of activities or the status of the wetland at this point. Vulnerability analysis of level of threats on wetland is crucial for understanding the impact they cause on the health of the wetlands, which in turn leads to the development of a suitable wetland strategy. So it's a holistic coverage of the different aspects, including the management strategies that are necessary for helping the wetland to recover if it has been degraded. Wetland vulnerability is part of a broader process, as I've mentioned, of assessing wetlands, which include gathering and analyzing or analysis of data through inventories. So people who have worked within the wetlands sphere now know that most of the activities that are being done or that have been done back then were things including inventories. So during inventories, that's when the data is collected. Maybe the boundaries are mapped or marked and so forth. And all this also look at the ecosystem services or the functions of the wetland. So all these are included during the inventory of the wetland. and to generate information at the end of the day, which is needed for decision makers within the wetland arena. Analysis of wetland is necessary, more especially in Africa, where the health of valuable wetland ecosystem is increasingly under threat from various drivers and pressures. So you find that most of our governments are considering giving away the wetland or putting developments in the wetland in the expense of industrial growth. And they seem to look at the profit of today, but they seem to not realize that these wetlands, as they're existing, contribute a lot to human life in terms of the functions, the services they provide to the communities and even to them. And you probably, if you see some wetlands in developed countries, are really considered as a treasure for the country and so much protected to a large extent. But in Africa, we are seeing this not the same. In yesterday's discussion, the different participants who talked about the aspects of degradation in their countries highlighted key things that are happening, and they're seeing that something is not happening well or somebody is not doing something. And we are hoping that during this session of the training, we are going to change what is happening and probably highlight using the different GIS tools and the Earth observation data, how the decisions can be improved as far as wetlands is concerned. So vulnerability of wetlands analysis basically is to identify systems that are at risk, and these systems should be at the greater risk. To aid in identifying factors that make a wetland vulnerable. Another is to prioritize resource allocation to most or least vulnerable wetland systems depending on the goals. So the reason why we are doing analysis of vulnerable wetlands is to consider these 4 factors. The last one is basically to estimate the inability of an ecosystem, which includes the wetland, to tolerate stresses over time and space. So we want to look at the EO-based method for assessing wetlands. Here is a conceptual framework for wetland vulnerability analysis. So yesterday we looked at the different things. First, we talked about the stakeholders. So on the extreme right and the extreme left, you'll see that we have experts and then we have the stakeholders. Now, each of them has a contribution at the end of the day to analysis of wetlands using the Earth observation data and the GIS tools. So on the topmost, you'll see that you start with vulnerability conceptualization, and we are going to go through this step by step. How do you conceptualize the vulnerability of a wetland? So next, what you do is you identify indicators or variables and make selections of the required data sets for those indicators or variables. And then on the right-hand side, the stakeholders have an input in the weighting of the indicators and the vulnerability domains. So you'll see that on the left-hand side, you'll see that experts have an input in identifying the indicators and variables, as well as selecting the required data sets. So we'll later see what really compose these experts. And yesterday we saw what compose of the different stakeholders. But in most cases, when this conceptualization is being done, the selection of the required data sets and identifying the variables, as well as the weighting, both the experts and the stakeholders actually come together. It's not like they're working in separate, but they come together as during, for example, a focus group discussion, and then they can be able to go through this process together. But you realize that an expert will have more knowledge in terms of identifying the indicators and selecting the required Earth observation data sets. And then opinions and so many discussions from the stakeholders will help the expert to assign the different weights. Because the reason is because most of the stakeholders are actually the local communities or the local leaders within the locality of the wetland. So you'll find that they have more understanding in terms of the benefits, the functions, and the factors being affecting these wetlands than the expert who has a general idea of how to assess the wetlands. So their opinions will matter most, and it will guide the expert to assign the weight. When we say assigning the weight, for example, in urban center, wetlands that are located in urban center, in the level of factors or exposure or things that affect them may differ with that are in the rural areas. Also, you'll find that if within the city, you'll find very few people collecting water from the wetland directly. And for them, they prefer the purified water. Of course, some do not accept, or they still ignore this fact that at the end of the day, even when this water is purified, this tap water is purified and maybe pumped to your house, it's actually coming from the wetland. So in that case, the person will think of a wetland as not directly linking it to the source of the water of the household, but yet in the rural areas, the level at which the wetlands support the human life directly is very much noticed or apparent. So the level of importance will vary, and this importance is what we are calling the weighting of indicators and assigning the vulnerability domains. Now, after the data sets and the weighting values are obtained or are available, then what is done is we shall now later see that this information needs to be normalized. Okay? So the normalization of this information will help in removing, for example, the outliers, okay, extremities of the data. And then also you realize that you're bringing different kinds of data sets together. You're bringing continuous data sets, you're bringing data sets of different scales. Others are numerical, others are ratios in terms of the formats or the scales of measurements. So all this needs to be normalized, and this will help in removing the cumbersomeness of bringing the different sources of data sets and from different scales together. Now, after normalizing individual data sets, you then aggregate these data sets, and you can use a regular grid. A regular grid is basically a squared sort of thing within the GIS environment. And then you do the linear weighting combination. Now, the linear weighting combination, the weights that we are talking about in the weighted linear combination is actually coming from up here during the weighting of indicators by the stakeholders. And then you generate vulnerability indicators at the end of the day. We are going to do this process step by step. Yes, we may not have a very clear stakeholders in play, like available during this training, but we shall assume that you will actually be the stakeholders and the experts, and then we'll run through this process step by step. There's a tool that has already been developed based on this concept, or based on this conceptual framework. And that tool is the one that later we are going to use to run this. But in the back end, the concept of that tool is coming from what we are seeing here. So after that, when you have, just like you're doing something in a computer, you need to do the validation. You need to check if really the results that you're having are correct. So what you do is to run a sensitivity and uncertainty analysis. And then when you do that, you'll generate a model. And this model, the reason why we are calling it a model is because you're trying to give an abstract of actually what is happening out there. So after running sensitivity analysis, if the values really correspond to what is available in the field, remember, when you're doing this kind of work, you'll go to the stakeholders in the rural area or in the vicinity of the wetland, have them come together, give you ideas about the wetlands, the different functions and all that together. But later when you run analysis, you have to go back and do a presentation. So when the presentation is done and really there's a disagreement between what you're showing and what the local communities actually know better, they will say no. And if they say no, you go back to the drawing board up and then you follow the same until you come after correcting the issues that they will tell you. But if there is a full agreement and they're like, oh yeah, that is exactly what we have seen over years in this wetland, then you'll be able to visualize the vulnerability. And in this case, the vulnerability visualization will be in terms of different scales, whereby it's an index from a certain value to another value. We are going to see this in details as we move with the presentation. So next, we want to now say, okay, after conceptualizing all these ideas, we need to narrow down to how it's supposed to be done, okay? One, this is basically going to show you the different steps that one can use to perform wetland vulnerability assessment or analysis. So in this work, we generated 5 steps, and these steps, one looks at the conceptualization of the wetland vulnerability, which in part we have already done in the previous slide. And then second, what you do is to identify factors or variables relating to the wetland vulnerability. This also we have talked about it. The little that we have talked about is the categorization of factors into 3 domains. Now, we mentioned in the previous first slides that a vulnerability of the wetland is related to exposure, okay, these are basically the factors that or events that risk getting the wetland degraded. The sensitivity basically looks at the state of the wetland. If the wetland is in a very good state, then the level of sensitivity it has is low. When a wetland is in a very bad soil state, let's say a wetland is being they're filling the wetland with soil. Okay, you have those mainly in urban centers. They keep filling it with soil because they want to maybe construct an industry or so forth. So when they do that, the level at which the sensitivity of a wetland to dry is really, really very high. So it's at that point, a wetland is very sensitive to being completely degraded in case something like that is happening. And then also the other part is the adaptive capacity. So the adaptive capacity is something people also refer to as resilience. We are going to see these terminologies are being used by different science communities, but they refer to the same thing. Next, what they do, or the next step, is to score or to weigh each factor based on the level of influence to vulnerability. So if, for example, you have drought. Okay, drought is due to climate change. There is a long dry spell, okay, that is being experienced in the locality of the wetland. And then you have also urban development as another factor that is affecting or making the wetland vulnerable. Then you will decide and say, okay, looking at the status quo of this area, I don't see, we have experienced drought for the last 10 years, maybe one, so we have never even experienced drought. But then you see that the level of urban development or built up areas in an area is increasing and are making this wetland more vulnerable. Then you actually say, okay, urban or built up development takes a bigger influence in making this wetland vulnerable. So you'll give it a bigger score or a larger weight. And then the drought, which is one of the factors that are affecting wetlands, you'll give it a low score because you have not experienced drought in this area or in that locality for the last 20 to 30 years. Next, then you combine the weighted factor. So basically, after assigning weights to the different factors, you combine them to generate what we are going to call the vulnerability index of a wetland. So those are the key 5 steps when you're using the GIS and the Earth observation data that you have to follow to analyze or assess the vulnerability or the level of vulnerability of a wetland. So I've spoken a lot, but would like to have a 5 minutes break. And this 5 minutes break is basically you're going to try to reflect the different things that I've talked about. But at the end of the session, my regulator of today's session mentioned that it's very important that we have some of these trainings or sessions. It's very important that we make it a bit productive in a way that we give a lot of contribution coming in from different sides. So we are here to learn from each other, and we need to learn something also from you. So during at the end of today's session, in the last hour of today's session, we are going to give opportunity to different participants, and we will just want one per country. This participant basically is going to look at these are some of the questions that you'll be discussing. One is, what are your country current approaches to assessing wetland degradation or vulnerability? So you prepare for that ahead so that when that time comes, feel free to put up your hand, and then you'll be given an opportunity to make this discussion. And then also the next one is, at what stage is Earth observation data being used in assessing the degradation or vulnerability of wetland in your country? So that will give opportunity to 10 participants, and each of them will be given 6 minutes. So prepare for that up front. Meanwhile, let's have that 5 minutes break and then continue. The reason why we put this break, because we are going to go to another technicality which needs you to be fresh in a little bit. Thank you. Okay, welcome back from that break. So I just want to look at some questions that were coming through the chat before we go to the next session. One quick one. Okay. Okay. Grigory, you're asking, are exposure and sensitivity considered as personal judgment? Yes. It's a personal judgment, but based on scientific proof and also based on what has been considered in other parts. What is very important here is that you, after knowing some of these factors, you should be able to know what is an exposure and what is sensitivity as far as the wetland is concerned. And we're going to go much deeper into how do you categorize these factors to be an exposure factor and what is a sensitivity factor. Okay. Next one, somebody, Stud one, you need to rename yourself because we may not be able to know what you mean by Stud one. So he's saying, does this weight depend on the locality or their specific locality? And I think somebody has answered you there. Nalule Mary said, I think it depends on locality. And we have explained this, that when you're doing vulnerability or assessment of wetlands in a rural and urban centers, you may not find the same factors playing out equally. Okay, so it depends on the geographical location of this wetland and the different components within the locality of that wetland. So keep your questions coming. As much as possible, we'll keep discussing, and also those that will come at the end of the training, at the last hour of the training. Theogene, I think Ingbabire, sorry about my accent in mentioning your name, no offense, is asking what are required parameters to analyze sensitivity of a wetland vulnerability. We are going to come into this next so that you will be able to see which data sets fit where and why did we decide to consider them within the sensitivity layer. Are the steps internationally applied? These steps may not have the international application really, but based on the different expertise that were in this working group, this was the agreeable steps that could work for analyzing the different wetlands. Also, they are based on the literature. We are going to see some of the case studies. We are going to watch a video of a case study that was done in the coastal wetland ecosystems. So we'll also learn that this is actually something that is being applied in different parts. Does the model can be applied to all? Okay, Ubalem, I didn't understand you very well. Yes, I'm going to share my screen. Thank you for those feedbacks. I'll be looking through the chats and some of the questions that will be coming, I'll be answering. But just finalizing from James Taebwa says, the wetland vulnerability assessment seem to employ quantitative elements. How does it capture qualitative data, which I think is equally important? Yes, James, we are going to answer some of these questions in the next presentation. How do you include qualitative data or information within assessment of vulnerability wetlands? Okay, so in the previous slide, we looked at this step-by-step workflow on assessing wetlands or carrying out the wetland vulnerability analysis. And we mentioned that one is conceptualization, two is identifying the variables or factors, three is categorization of these factors into domains of sensitivity, exposure, and adaptive capacity, and then scoring the weight or weighting of these factors, and then combining or aggregating this information to generate the different levels of vulnerability, which are referred to Wetland Vulnerability Index. Moving on the first step is the conceptualization, which is an important critical step in vulnerability analysis for wetlands. So this is to identify the threats to the wetland ecosystem, sensitivity to the threat, and the coping capacity, which is also normally referred to resilience. So WVA method should be based on existing best practices of environment assessment. And in this case, we are adopted the DIPSA framework, which my colleague hinted on yesterday. The DIPSA is an acronym of driver, pressure, state, impacts, and response. So it's the framework that was adopted for the conceptualization of the WV, which is the wetland vulnerability. So before I go further, I want us to watch this video, which is accredited to Wageningen University, which explains explicitly on the wetland vulnerability or the DIPSA framework rather. So I'm going to stop sharing and then I'm going to share the video.
Environmental problems are complex.
Okay, I think I'm just going to play the video, not from YouTube. Internet seems to be poor today.
Environmental problems are complex since they mostly have multiple causes. The severity of the problem depends on a chain of interacting relations. Environmental problems are complex since they mostly have multiple causes. The severity of the problem depends on a chain of interacting relations. In this clip, I explain how to structure environmental problems using the so-called DIPSA framework. DIPSA stands for drivers, pressures, states, impacts, and responses. The DIPSA framework is a tool for describing and analyzing environmental problems in a consistent and transparent way. It helps you to better structure environmental problems and answer questions such as what causes pollution problems and what are the adverse effects. Let's take eutrophication as an example. This problem occurs when there are too many nutrients in the environment. These nutrients come from several sources. Agriculture is one of them. In surface waters, this can lead to harmful algal blooms. Algae can be toxic, and algal blooms can lead to anoxic situations as a result of which fish may die. It is a problem for ecosystems, but also for recreation and fisheries. A problem like eutrophication is caused by a chain of events. I will explain these for bioplastics. The first elements are the drivers. These are the human needs that form the basis of the human activities. In this case, that is the need for packaging materials such as bioplastics. The second element are the pressures. These are the human activities undertaken to fulfill the human needs. In this particular case, it is plant production and processing the plants into bioplastics. The next element is the state. This refers to the state of the environment. For example, the pollution level of soil, air and water, and all processes related to this pollution. An example of a state process in this particular case is the nitrate level in the surface water. The impacts are the changes in welfare or well-being of humans, which are caused by the state changes. In this particular case, it is the harmful algal blooms and their impact on society. The final element are the responses. These are the actions undertaken by groups or individuals in our society, or by the government, to prevent, compensate, or adapt to changes in the state of the environment. In this case, these actions could consist of cleanup activities, alternative production, or a change in human behavior. Describing an environmental problem in terms of drivers, pressures, state, impacts, and responses provides insight in the structure of the problem. The drivers, pressures, and responses belong to the societal domain, whereas the state and impacts belong to the environmental domain. This interaction between society on one hand and the environment on the other is typical of environmental problems. It is the playing field of environmental science, the discipline that studies the interaction between society and its environment. Let me now use the DIPSA framework to illustrate the different interventions possible to tackle the problem. Each intervention acts at a different place in the intervention chain. Let's start with one possible intervention, cleanup programs. This intervention acts on the state variable. It improves the state of, for instance, our surface waters. But the effect will be temporary if the causes are not tackled. Moving up the chain, another intervention would be the adaptation of production processes. By increasing the nutrient efficiency in plant production, for example. Moving even further up the chain, we could also try to change people's behavior. For example, by reducing the amount of packaging material used. I'm not saying this is always a feasible or wise solution, but it is important to keep an open mind and ask yourself, what can I do at this point in the chain? At the other end of the chain, the side of the impacts, you can also intervene. An example would be to collect algae from polluted water. Your interventions do not need to be restricted to the boxes of the DIPSA framework, but may also act on the links between the boxes. To summarize, the DIPSA framework can be very useful to describe the causes and effects of environmental problems and to identify possible solutions. It can be used to analyze environmental problems in a consistent and transparent way, and it can be used as a basis for more detailed analysis of the problem at stake.
All right. Thank you so much for your audience. So, in summary of what we have just looked at in the video, is that the DIPSA framework is used to assess and manage environmental problems. The drivers are basically those socioeconomic and sociocultural forces or drivers of human activities which increase or mitigate pressures on the environment. The pressures are the stresses that human activities placed on the wetlands, or basically they are the needs that people want to obtain from the wetlands. They may want to obtain or utilize the wetland. So either of them, whether they want to just utilize it or obtain goods, functions, or benefits from them, all is the pressures as far as the DIPSA framework is concerned. This may, for example, extraction of water from the wetland. They're actually not using the wetland, but rather they're extracting its goods and services. It could also be the fishing. So the moment it's done beyond sustainable manner, then it becomes the pressure as far as DIPSA is concerned. The state, on the other hand, is the state, basically the current condition, or those elements that look at the condition of the wetland. The impact are the effect of the pressures and the drivers on the wetland. Remember, it doesn't have to follow through the drivers to pressures to state. The drivers themselves can have an impact directly to the wetland, bypassing the pressures. Then the responses, which we shall later realize that is actually also adaptive capacity, as far as vulnerability definition is concerned, refers to the responses by the society to the environmental situation. It doesn't necessarily mean the societies have to act alone, but rather the wetland itself also has ability to cope or to respond to these effects. I'll give, for example, around my village area, there's a wetland that most people like grazing from during the dry season, but you'll find that these wetlands flood a lot flood with water during the rainy season, and this helps the vegetation in the wetland to recover from the overgrazing. So that's the response that the wetland itself is regulating to combat the effect of the pressures and the drivers. So this conceptualization of vulnerability based on the DIPSA framework helps us to categorize data easily, okay? Because we clearly can relate what are the drivers, what are the pressures, what are the states, what are the impacts, and what are the responses. But you'll find that, so looking at what we mentioned and also some of the questions that are streaming in, people asking, so what exposure, what consists of exposure and sensitivity, which I'm going to later elaborate more in the next slide. But going further into the DIPSA framework of driver, pressure, state, impact, and response, we'll see that categorizing our data sets in relation to the DIPSA framework brings in the population growth or the density, climate change, urbanization, settlement, the different socioeconomic needs to be the drivers of the wetland degradation. And then the pressures are the actual activities. So the moment the land use, for example, is being used for agriculture, then it is having, so the need is food, which is the driver or the socioeconomic need. And then the way this is impacted on the wetland is through the change of the land use or conducting what we call the wetland fragmentation. So after the pressures, so you'll see that under the pressures, things to do with land use change, wetland fragmentation, those are the examples, are the pressures that can be exerted on the wetland. So the reason why we are giving these specific examples, because it is very easy to obtain Earth observation-based data, which looks at the population density, the climate change, urbanization, and so forth. And also for the pressures, we know, or we could have used the land use data quite often. So this is categorized under the pressure which can be obtained based on the Earth observation data. Next, the wetland state. You could look at examples, for example, changes in the water quantity. Okay, so when the water levels, let's say in a lake or in a river, decreases, that's the current state, okay, of the wetland, with the dedicated or the current amount of the water quantity, quality, and the habitats within it. So those are all things that explain the state of a wetland, and all this we shall see at a later stage can be related into an Earth observation data. Then we have the impact. So the impact is the results of the drivers and the pressures acting on the state of the wetland. So if there is an habitat loss, that means there could be an agricultural activity in the wetland that has affected the quantity of the water, the quality of the water, as well as destroying the wetland itself. So it will lead to the habitat loss. So the habitat loss, we know that habitat is where the different living things live or stay or live in. So if the water levels have decreased, then that means no enough oxygen for the fish, and the fish is going to die. So that has affected the habitat of the fishing or the aquatic animals in that regard. If we have maybe some mammals that live in a wetland and eat the wetland vegetation, and if there is effect on the vegetation of the wetland, then that will cause the effect or the loss of their habitat. The responses are the management plans. Yesterday we had one of our participants share that the current state or the current activities that they're doing in their country is to generate the different management plans of the wetlands, as well as creating a formulation of policies regarding the protection and the utilization of the wetland. We all know that all over the world or in different parts of the countries that we are in, the population is increasing at a very alarming rate. And the demand for resources has also increased. South, north, the demand has really increased. And this is also affecting the fragile ecosystems that we consider wetlands. Now, why wetlands? Wetlands, as mentioned yesterday, has support and provides a lot of needs for the human survival in terms of the different functions, the goods, and the benefits that is obtained from the wetlands. Now, when you're conducting a vulnerability assessment of wetlands, there is an aspect of the geographical location. So you'll see that within the global, national, and the local scale, the drivers and the pressures are the ones that lie there. And within, and as well as the response and the impact aspects can be globally attained or assessed. But the state of the wetland is done at the operational scale. This is really not something very vital for us to think about now. But what we need to know is that if you conceptualize the environmental problem, which is the wetland degradation in this case, how does the DIPSA framework helps you to put things together? How does it allow you to digest in details the different components of the wetland. Now, we have used the DIPSA framework to conceptualize the wetland components or factors in a wetland. But when you are looking at vulnerability, based on the Ipcc definition, vulnerability looks at the exposure, potential impact, or rather it looks at potential impact minus adaptive capacity. So therefore, within our wetland framework, how do we relate the vulnerability based on Ipcc definition? Now, just a recap, exposure is the amount and the rate of change that a species or a system experiences from the direct or indirect impact disturbance. And sensitivity refers to the characteristics of a system that are dependent on specific environmental conditions. The terms might be so ambiguous and long, but we'll make it a little bit easy for us to understand. And then also the last one is the resilience, which is normally called also adaptive capacity, which is the ability of the system to cope and persist under the changing condition. Now, based on Ipcc definition, vulnerability is impact, potential impact minus adaptive capacity. This potential impact is obtained by adding exposure component plus mathematically it's by adding potential exposure component plus the sensitivity, and then gives you potential impact. Now this potential impact is the one that you subtract from the adaptive capacity. Now diving further into the two concepts that we are looking at. One is the Ipcc definition of wetland vulnerability. Another is looking at the conceptualization of the wetland variables or factors. Then now we need to bring this together and say, okay, how do we categorize, how do we merge the different concepts together? One, Ipcc is basically defining vulnerability in terms of environmental changes, okay? And it's a broad term. So now we want to use it to bring the aspects of or the conceptualization of the wetlands vulnerability within the general vulnerability definition. So we have talked about exposure, threats. So within the DIPSA framework, we see the drivers and the pressures. So the drivers and the pressures within the DIPSA framework falls within the exposure of the Ipcc definition of vulnerability. And this, based on the Earth observation data, include aspects of population pressure or density, wetland agriculture, climate variability, which can also be defined as the drought, built-up area development, we talked about the settlements earlier, as well as the general degradation of the land, or including the wetlands. Next is the sensitivity. So within the DIPSA framework, sensitivity is the state. Now, what data can we categorize within the state? So issues of the vegetation, which is assessed in Earth observation data as the vegetation index or the normalized vegetation index, difference of vegetation index. The aspects of the water quantity, quality, ecosystem services, and the wetland seasonality. So wetland seasonality, in this case, you're basically looking at the permanent and the seasonal wetlands. We looked at the Ramsar definition of wetlands and also the different categorization of the different wetlands yesterday. And we also see it here coming up under the sensitivity, which is the state of the wetland. So combination of exposure and sensitivity gives us the potential impact. So the potential impact under the Ipcc definition falls within the impact of the DIPSA framework as well. Then later we have resilience, which is also the response or the capacity, adaptive capacity, is also having a number of data sets, and these are just examples. So the wetland protection level, if the wetland for some countries or for other places, wetlands are within the communal land, and you might find that the level of protection equated to it is not the same as a wetland that is within a reserve or a forest reserve area. So you might find that the wetlands that are within a forest reserve or a wildlife reserve is more protected than that is just in the open woodland or savanna or within the communities having a certain land tenure system. And then the resilience or the responses are the laws and the policies that the different people have talked about. Now, going upwards, we can now use potential impacts and resilience to be able to generate the wetland vulnerability. So this is a process that starts from down, from looking at exposure and sensitivity, upwards, looking at potential impacts and resilience to generate the wetland vulnerability. Now, the fourth step is the combination or the weighting or generating of scores for the vulnerability factors. So once the weights or the scores are assigned to factors or indicator variables, remember we discussed this, that the stakeholders have a big role to play in this case to say, okay, looking at this wetland, population density will have a higher score compared to the drought, for example, that I mentioned earlier. So the factors should be combined in three main Earth observation domains. So remember, under the DIPSA framework, we had different factors that fall within the drivers, within the pressures, within the state, impact, and the response. So we need to, just like I've just discussed above, that we need to categorize them into the three vulnerability domains, which is exposure, sensitivity, and adaptive capacity. So this is mathematically done using this equation. Remember, we are saying that someone mentioned in the chat that most of the data sets that we are used are quantitative in nature. So how do you utilize the qualitative data? So the qualitative data under the vulnerability assessment methodology that we are proposing or that we have used here is captured during the weighting. Okay? I'll give, for example, if the policy in the utilization of the wetland is strong towards its conservation, that means the wetlands in that country will be more protected and therefore less vulnerable. So if, for example, the policies are there and the level of enforcement is low, for example, we don't see that very common in rural areas, but in developed areas or urban centers, we see a lot of eyes and enforcement factors being done on urban wetlands. Therefore, we'll give it in terms of the weight to be more protected. So therefore, it will have a less value for vulnerability. I hope that is not confusing. So when the law is strong and the enforcement is strong, that makes the wetland more protected. So if it is more protected, then the level at which it is vulnerable to degradation will be low. But remember, not only one factor determines the vulnerability of a wetland. So it's a combination of that. So if the law is well protected, or the wetland is well protected in terms of the laws and the policies do not apply to the climate change. Okay? This is something that some of us who still believe in God is being controlled by nature. So the laws and the policies will not control the aspects of climate change or the drought events. So that should also be assigned separately. The weight should also be assigned separately based on what is the current status quo of that wetland. And then also the sensitivity varies. Okay? You might find that a wetland in urban center has more water, and it's actually more, what do I say? It's more, the level at which it has water throughout the year, or its seasonality, is constant. Okay? Maybe because there is a lot of industrial water coming out from the different factories, so you see the flow of a stream constantly there, compared to probably those in rural areas which are seasonal, whereby you find that during dry season they are completely dry, and then suddenly when the rain come back, they are completely filled up or flooded with water. So the state of the wetland also vary based on the locality. And that's why we are saying that, okay, this process of assessing the vulnerability of the wetland, even though it is using the Earth observation data, there's an aspect of involvement of the stakeholders and the experts that understand the status quo of that wetland much better. So separately, using this formula, basically the sum of the weighted factors, whereby you have different components or factors for the exposure. So you sum them up, multiply by the weight that the stakeholders provided, and then you generate the exposure. But later, after generating exposure, sensitivity, and resilience, you sum them totally up, and then you'll be able to generate the index. So an index basically looks at the different levels of a system, okay? Whereby you see high level, moderate, and low. So basically you're looking at the different levels, and that can be related to an index. So talking about it further, an index can be used to analyze the vulnerability of wetlands, which in this case we are referring to be the WVI. The combination of each domain, as I've mentioned, to vulnerability of a wetland should be considered in computing the index. And with this, the weights provided by the stakeholders are assigned to each domain, and the WVI can be computed using that equation. And the results of this analysis can be visualized on a map. So this training titled the use of GIS tools and Earth observation data to do assessment of the vulnerability has to, at the end of the day, result to a production of a map, which is a geographical object that can be used for decision making. Now, the things that I'm talking about can be clearly summarized in this table. That you have a wetland, in this case we have a case study of Lubiji, and then you have the three wetland vulnerability domains. The domains are the exposure, sensitivity, and resilience, or adaptive capacity, the SC. So you generate factor or data, okay? The factors that I'm talking about within the Earth observation field are called the data sets, or the EO. So you'll see that these factors land cover, land use, population, drought, degradation, built up index, which look at the level of built ups within the area. So, based on this provision of the stakeholders' analysis or their own input, you'll be able to generate the weights for these different factors, where you have the 20 assigned to the land cover, and then 10 is assigned to drought. But in this case, you're assigning 30 because maybe this wetland is located within a urban area or the trading center. And also within the sensitivity, you'll have ecosystem services, the NDVI, the wetness index. These are examples of the factors or the data sets within the Earth observation field that can be generated to measure the sensitivity. And then the resilience is things to do with the inundation or the wetland extent or the habitat in that regard. This is not conclusive. Basically, it varies from each wetland to the other. And a good definition of why you choose to allocate a factor to a particular domain is based on the level of expertise you have in the wetland. So later we see that these domains are combined, but before they are also combined, they are also assigned different weights. So this is basically to enable remove the aspects of biasness, okay, in your analysis, that you provide the weighting at different levels in order to remove the biasness that you could be having. So quickly, we are going to just watch this case study video, which is based on the vulnerability of coastal wetlands.
Good morning. My name is Roman Canul, and I will talk about a probabilistic approach to a coastal vulnerability index, a tool for coastal management. And the anthropic pressure, mainly land use change and urbanization, are the main problems for the coast. And in recent years, several coastal vulnerabilities. Good morning. My name is Roman Canul, and I will talk about a probabilistic approach to a coastal vulnerability index, a tool for coastal management. And the anthropic pressure, mainly land use change and urbanization, are the main problems for the coast. And in recent years, several coastal vulnerability studies and risk analysis focus on coastal erosion have been developed. The study area is the state of Campeche, located in Mexico. Campeche is part of the Yucatan Peninsula because it's approximately 520 kilometers long and is made up of sand and rocks. On this coast, we can find several coastal ecosystems with complex environmental dynamics, such as coastal lagoons, mangrove forests, and los petenes. So, why analyze vulnerability to erosion in Campeche? Well, because erosion rates of 7.97 meters per year have been reported with maximums of 21.86 meters per year, because Campeche has a strong and important oil-shore industry that contributes most of the national gross domestic product, because the coast is very attractive for the tourism industry and resorts such as Akbal and Campeche Country Club have recently been built, and because knowing the level of vulnerability will allow the implementation of adequate coastal planning. The objective of this work is to develop a methodology that allows evaluating coastal vulnerability to erosion by applying a probabilistic approach. For this, we have applied this methodology. First, research of the area, that is, available information, identification and selection of key variables, and their classification into physical and social variables. Later, the information was collated and databases were generated in GIS. Each variable was assigned a classification with a scale from 1 to 5, because was divided into segments whose base was the adjective, in Spanish, ajep. This is geographic area occupied by a set of perfectly delimited blocks. Then, we applied the HP framework. For this, we conducted a survey for 100 science experts in coastal zones. We calculate the weight of each criterion of our variables, and we calculate the CBI and express the results on a map. These are the 15 variables considered in the analysis, and this table presents the source where information was obtained, such as field data, government offices, and database. Here, I present the particular classification of each variable in a scale of 1 to 5, where 1 is very low and 5 is very high vulnerability. This section presents the application of the hierarchical analytical process, and this table explains the intensity values when comparing one variable with another, as well as the consistency coefficient required for the number of variables analyzed. This is the comparison table between the 15 variables, and here the values calculated for the consistency indices are presented. It is observed that the value of CR of 0.09 less than 0.10 was obtained. However, this value may be due to the fact that there were few experts in social science to respond, which generates that the social variables had less weight. And finally, the weight was obtained for each of the variables. It is observed that the geomorphology, followed by the coastal slope and the change of coastline, are the variables that, according to the expert, explain the vulnerability of an area. Finally, the coast vulnerability index was calculated applying this formula, the sum of the multiplication of the classification of the variables by its weight. The values were divided into 5 groups, from very low to very high vulnerability. For Campeche, only 3 categories are presented: low, moderate, and high vulnerability. However, we consider that the weight of the assessing vulnerability by deterministic methods may represent a low level of vulnerability. In addition, to not representing or considering the variations that may occur in each variable over time or space.
Okay. So next, what we need to do is to digest some of the things that were in that short video. The video was really, really very short, but I'm going to digest it further here so that we can be able to understand what was in the video. So the first thing that when you a recap of the conceptual framework that we had earlier is that you'll have a team of experts. So the team of experts in this case consists of a number of experts. One is you need to have a wetland expert. So somebody who has studied wetlands and have a lot of information and good understanding in terms of academic background or studies in the wetlands. So this is a person who could have maybe done a lot of research in wetlands and have a very strong knowledge on the different wetlands that can be available. Based on what we saw yesterday, my colleague explained the different types of wetlands. 2 is the GIS and the Earth Observation expert needs to be included within this team of experts. And then 3, you need to have the district or the local leaders included in this team. And then also the communities. The communities are actually the people who benefit or utilize the resources within this wetland. So, as we mentioned earlier, based on the study, you start by looking at, okay, what are the key domains in assessing the vulnerability of wetlands? And which is the first one is the exposure or the threats. Now, for the exposure or the threat domain, you generate a number of factors. In this example, we have factor 1, factor 2, factor 3, factor 4. You could have even more than just these 4. 2 is you generate sensitivity. So for sensitivity domain, you generate the different variables or the factors that we saw in that video. They had slope and so many things. And then addition of sensitivity and exposure or threats generates a potential impact value. Okay. The next, you generate also the adaptive capacity or the resilience and the different factors for this adaptive capacity. So in case of this study, you have 4 variables from the exposure, 3 variables as an example from the sensitivity, and then another 3 variables for adaptive capacity. So in terms of the GIS or the data layers or the Earth observation data, you'll have 10 categories of data sets. So this Earth observation data is mainly categorized or identified by the GIS and the Earth observation expert. We mentioned that in this team of experts, you'll have a wetland expert, you'll have a GIS person and remote sensing or Earth observation, and then you'll have the local leaders and the communities. So it is only the GIS expert or the Earth observation expert who will know that when a farmer is talking about dry spell, the Earth observation data for the dry spell is drought or which is measured from the deviation or the deviation of the rainfall or and the surface temperature and so many things. So you'll find that it's the GIS and the Earth observation expert who will know that which kind of data talks about drought, which kind of data talks about the loss of vegetation, which type of data looks at the loss of water quality and quantity. Okay, so it will be the GIS expert who will be able to split that up. But after doing that, the GIS expert will also go further ahead and do the normalization of this data. We mentioned that the data will be coming from different sources of different scales of measurements and sources and the quality and quantity. So they need to be normalized into one scale. And in our scale, we have a scale of 1 to 5. Okay? So for each factor 1, factor 2, factor 3, factor 4, factor 5, they have to be normalized or reclassified within the GIS environment from 1 to 5. Because the data could have, for example, slope. Slope could have different categories. You can have a slope which is maybe, let's say, from 1 meter to 2. 2 meters to 3 meters to, in terms of elevation, okay? So you could have up to 10. But doing the normalization or the reclassification is to enable you have all these variables or the factors from this having the same scale of 1 to 5. We are going to do this tomorrow, right through step by step, and we'll be able to see how this can be done within the GIS tools. So after doing that, using the AHP framework, which was done by Satu, we are going to see within the GIS tools, how do you access the AHP tool and how do you utilize it in order to generate the W, which is the weight. So the weight for each factor is generated, and also the weight for each domain is generated. When I say domains, I mean exposure, sensitivity, domains, and the resilience. So basically, these are the three main domains. So weights for each three main domains will also be generated from the AHP framework. Now, after doing that, you now have data sets classified into 5 classes, each of these factors into 5 classes. So factor 1 is classified into 1, 2, 3, 5 classes, factor 2 into 1, 2, 3, 4, 5 classes, and factor 10 also into 1, 2, 3, 4, 5 classes. And using the weights, so basically you multiply this data, which is in classes, by the weight that is provided to generate the exposure threat. And then also multiply the weight for individual factor, and then make an addition or the summation, and then generate a sensitivity component, as well as adaptive capacity. So when you do that, you'll be able to generate, remember, exposure plus sensitivity gives us the potential impact, and wetland vulnerability index, as we saw different classes, is generated by multiplying or doing a mathematical operation of potential impact minus the adaptive capacity. You realize that within the GIS environment tomorrow, we don't necessarily say, okay, potential impact minus resilience. You'll get a wrong value. So we shall see what tricks do you really use to calculate this mathematically without getting errors. For example, if I told you that if a wetland is highly protected, then it will have classes of 1 to 5 in terms of factors, but value 1 means that this wetland is less protected, and value 5 is highly protected. So if the resilience have a value of 5, then it will be highly protected. If it is having a value 1, then it's less protected. Now, in that case, you'll just do a multiplication of impact times the resilience to generate the WVI. But the trick is, on the back end, you need to know that the vulnerability is generated by subtracting potential impact, rather adaptive capacity from the potential impact. So we see that in this case, you're moving from up to down, from the experts to generating the wetland vulnerability index. And we are going to see that we are going to use a number of tools, but one of them is going to be the QGIS environment tomorrow to perform all these kinds of analysis. And then, giving an example, you have an observation data here, an aerial photo. And then through the process that we have just explained, you'll be able to have, or you'll be able to obtain the map showing the level of vulnerability of that particular area. To expand this further, you have this image being captured for this wetland, and then later you'll go further after doing all these processes. You'll generate the level of vulnerability of this wetland, whereby areas that are in red are actually areas that are more vulnerable to the wetland compared to the areas that are in dark green. So doing the sensitivity analysis at the end, when you overlay this with a clear aerial photo, you'll be able to see that actually these areas that are red in color are undergoing, maybe they're doing sand mining and sometimes also bricklaying, or generally a lot of soil is being excavated from these areas, and you'll be able to see the effect of the vulnerability or the effect of human activity and the climate change within this wetland. So, some of the strategies, I know you have explained more yesterday, you discussed a lot yesterday. So, one is to build resilience of wetlands and associated catchments to improve ecosystem services they provide. Ecosystem services subject is a very large subject, which you can further do more research on, but it's a very interesting thing when you talk about valuation of ecosystem services. This makes wetlands valuable in monetary basis. So it's very difficult to defend some of these aspects of the science or the importance of wetlands to political leaders, because for them it's monetary aspect. They look at things in a monetary basis. So if you can engineer the monetary value of the wetlands through the ecosystem services, then it can make a lot of sense to the political leaders. Then building resilience of communities to improve livelihoods, as well as reduce dependency on wetlands and other natural resources. Another strategy is gazetting wetlands. This is in my country, Uganda. The wetland boundaries are being marked with the pillars to communicate to the communities that beyond this point, you're not supposed to indulge into activities that will affect the existence or the functionality of this wetland. So they're putting pillars in the boundary of the wetlands. Promotion of awareness and environmental literacy. This is very important because you find that the reason why probably some people look on when the environment is being degraded or when the wetlands are being degraded is because they don't know the effect of some of those activities. Sometimes this is a very malicious activity, maybe that somebody just maliciously want to deprive the values and the goods from the wetlands by setting up an industry warehouse within the wetland, and then the communities lose all the benefits that they used to obtain from the wetland. So awareness is very important, and also encouraging the literacy in environmental management. So we're going to have maybe a 5 minutes break or less, and then we want to prepare you for this discussion section. So I just need to edit this. I meant 10 participants, and they'll be given 6 minutes each. Hopefully we shall be able to have 10 within the remaining time. But what we want the discussant or you to discuss, you basically have to raise up your hand, and then I'll be able to see you quickly and pick you, is what are your country current approaches to assessing wetland degradation or vulnerability? Now that you've understood what a degradation is and what a vulnerability is, what are the current approaches that your country is doing to assess this degradation and vulnerability? And if in any case, at what stage is Earth observation data being used? Okay, Earth observation data, we're going to see more details of what an EO is, where do we get these EOs, and how do we manipulate it to use in assessing the vulnerability of wetlands. So a quick one to you, back to you. I'm looking at the charts quickly as I wait for you to start your contribution. There is quite a lot of discussion in the chat. I'll start from down up. Malay is asking, how can the expert opinion on assigning weights be checked or verified for accuracy? Of course, we say that there's a stage at which you do sensitivity analysis. So you basically do analysis and then go back and do the accuracy assessment or reconnaissance of what you've really done, and then see, does it really match? For example, I'll just quickly go to the previous slide. Something is jamming my PC up. So for example, after you doing analysis of this kind, you can go back with your GPS and go to this location and then see, is this place really degraded, or the analysis that I've really done is not corresponding with what is on ground. So if that is the case, then you should be able to investigate. Since you've done your analysis in a procedural process, or the workflow is very clear, you'll be able to identify that actually the reason of this, remember, you're within the GIS environment, you're overlaying data together. So you realize, actually, I have provided a bigger weight to this, yet it's not supposed to have that. Maybe that's why I am having something like this. So you should be able to investigate that at the end before you say, my analysis was successfully done, before you share it as well. So yes, that can be done. My chart. Social scientist is key expert in the process, I believe. Yes, Susan, social scientists, remember, yes, we may have a wetland expert within this team, but also within the local leaders. Most of the local leaders are actually looking at the social aspects of the wetland state or benefits. So they actually know when you go to a district, for example, and you meet the natural resource person, most of the time what they'll be discussing and telling you is that communities in this area have really lost ABCD. They have lost source of income. They have lost the level at which they used to thrive well in these wetlands. They used to do a lot of fishing. So they look at all that arrangement of the social aspects within that. Edward Senyonjo, nice meeting you here. So Edward is highlighting is a very senior person in this area. Apparently, the local leaders have considerable weight in determining the weights that are used in this discussion and analysis. We have to appreciate that this process requires a certain level of technical capacity to work with. So how do we advise to go about this in instance where the stakeholders are not able to provide reliable input, including, for example, in this case, the weights to this analysis? Okay. Now, and the reason why the wetland expert is really coming on board is also to fill some of the gaps that the stakeholders may be having. It is very true that sometimes if you don't explain very well to the local leaders what you actually mean by vulnerability, you may not get information. So the first thing is to make sure that the discussion document. In this case, I'm trying to mean things like the focus group discussion document that you're having uh, needs to be maybe even interpreted in a local language and clearly explained to the local or the communities to quickly understand exactly what scientific aspect of vulnerability in terms of those domains are you really referring to, so that it will be very easy for you to give them an opportunity to contribute. But if you don't, then you may not get a lot of answers from them. I hope so. Danish is saying uh, it appears that local knowledge perception is incorporated into the method at the weighting stage. That's true. How much is enough stakeholders consultation to ensure that the given weight truly reflect their qualitative opinion or understanding? Uh, to At this stage, I'm really a GIS expert, so I am not a wetland expert. But relatively, you need to also you might have a large number, but the large number that you have tentatively cannot actually bring out information. So you need to be very, very careful, and you need to investigate this further. Which stakeholders are you going to involve? Okay? Because if for example you want to understand the aspects of degradation of a wetland, and then you bring an investor who is actually interested in destroying that wetland, you may not get very good results at the end. So the choice and the selection of stakeholders that my colleague mentioned yesterday, I'll give her an opportunity to say something in this regard, because I see most of the questions are coming around there. But she's going to give us more highlight on this. But you need to be very, very conversant and really know how best to select the stakeholders, because the weight is influenced a lot by a good understanding of that wetland, and which you can hopefully get from the stakeholders. Will the type of wetland significantly affect factors in vulnerability index? Yes, the type of the wetland significantly affects it. I gave an example. If you have a seasonal wetland is whereby during certain seasons they dry up, and then they uh, during the rainy season they flood with the water. Now, if, for example, during dry season, an investor will have an opportunity to actually go and fill that wetland in a way that he creates even channels to allow water to flow, but at the end of the day, he has already destroyed the wetland. So during dry season, that's when they'll do that. And then when the water comes back, the wetland will be already gone. But also, the vulnerability of the wetland is not really being looked at the existing and the non-existent of the wetland, but rather also looking at how uh, the species or the animals, the birds that survive from this wetland are vulnerable. So it's also looking at the content of the wetland as well as the wetland itself. So if the habitat of some of these species is destroyed by destroying the wetland area, then that means they will not survive. Okay, as I go through the questions, I'll come back shortly later, but I want to see how many people have their hands up so that we start the discussion. Okay, I'm going to start with Rukundo. Rukundo, you can turn on your. Yeah, come in.
Yes. Thank you. My name is Rukundo Jean d'Amour. I'm from Rwanda, University of Rwanda Engineering. So in Rwanda is endowed with wetlands that contribute significantly to environmental sustainability, community livelihood, and carbon sequestration. The government of Rwanda has put in place legislation to manage all its natural resources, including wetlands. However, there are signs of wetland degradation due to factors including the draining of wetlands for agriculture, urban and industrial expansion, and poor use of wetland catchments, leading to saturation and pollution of wetlands and rivers. However, Rwanda, they have some current approaches to assess wetland degradation and vulnerability. First is to promote and identify wetland protection and restoration and rehabilitation of degraded wetlands. Uh, Strengthen existing wetland research and encourage conservation and restoration of ecosystems critically threatened by climate change. Also to ensure protection of wetlands, riverbanks, hilltops, and slopes from unsustainable practices to prevent soil erosion and environmental degradation. Also to ensure that developmental activities within wetlands or in the buffer of wetlands conform with environmental impact assessment processes and procedures. Also to develop a master plan and implementation strategies and approach to assess the wetland degradation. Also to identify all polluted wetlands and develop a decontamination plan including the use of environmentally sound technologies for pollution prevention and control and remediation. Also Rwanda, also they have many wetland protected areas, but they use uh, Earth observation data at a stage which is not most high, but in geoinformation science, well as remote sensing, play increasingly important role for sustainable environment, sound natural resources management, and socio-economic transformation in Rwanda. Also, advanced skills in geomatics. The more technical aspects for geoinformation are used in Rwanda. Thank you.
Thank you so much for those inputs. Quickly, today we want to be engaging, so I'm not going to talk so much. I want to give a chance to Wanyama.
Yes, thank you very much.
Yes, loud and clear.
Are you hearing me? Hello?
Yes, Wanyama,
Are you hearing
loud
me?
and clear.
I want to give I want to give my experience because I work with the Wetlands Management Department.
Yes. Go ahead.
Hello? Hello? Yes, I want to give
Yes,
my experience. I want to give my experience as somebody who works with the Water Management Department in the Ministry of Water. I have to try to explain, but some of those strategies come with the challenges. For example, when you try to build resilience of communities, it is an approach that is highly appreciated. And we have tried it in areas like in eastern Uganda and southwestern Uganda. We have tried to build resilience of the communities. We have tried to provide alternative livelihood to people. We give them alternative sources of income such that they can come out of the wetland and go ahead with such other options. But the challenge with that, in areas where I have not reached, you find communities are saying, for us, we can only leave wetlands if we only given also alternatives. And the source envelope is not enough to, to roll out the project to the entire country. So that has been a challenge, and we're experiencing it, and we really need to see how we can handle such communities that can only leave wetlands after being maybe given alternative livelihood or being compensated. Another challenge, another problem is when you are talking of some factors. There are some factors that really contribute to wetland degradation, But when it comes to quantifying them, is a problem. An example is politics. You find that during a political period, there is a high rate of degradation. You heard of recent when the president was in Eastern Uganda, when he said that people are free to use the wetland. That that statement, it prompted so many people and moved into the wetland. And I don't know how the system can quantify issues of politics into how can it can be quantified and contribute to the entire process.
Thank you.
Thank you very much.
Wanyama. Thank you so much. That is very true. The influence of the political atmosphere is very key as far as our uh, assessment of the wetlands degradation as well as the conservation is concerned. And that's why the policies and the laws are very key, and the level of enforcement. So it's very hard to enforce policy and law in terms of Earth observation analysis or the GIS analysis. But now, when you bring it in terms of the level of enforcement, the the level of influence of these political leaders as far as the conservation or the management or the of this wetland is concerned, that's when you can now be able to quantify a value. And somebody asked how what what is the range of these values. So sometimes in terms of scales, you can decide to use a value of 1 to 10, or you can decide to use a value of 10 to 100. So basically, you're saying 100 is having a higher weight, that is considered to be a high weight, and then a value of 10 is a low weight. Okay, and if you decide, you can say, okay, I want to have it in the ranges of 20s. In other words, you have a value of 10, then you have 30, then you have 50. Okay, or you can decide to just say, okay, I want to have 20, 40, 60, 80, and 100. Yeah, so those are the ranges. So the influence of these political leaders, as you've mentioned, has a very huge impact in the level of vulnerability of our wetlands or the different ecosystems. So we need to see that when you are doing these kinds of analysis, that should be in consideration and then put there in terms of the weight that you supply during the analysis. Okay, I want to give another person a chance. Whose hands is up? Please feel free to give your opinions and conversation. We have more minutes. So far, I've had 2 discussants. Anyone else? Just at the lower screen of your Zoom, you'll see a section whereby you can be able to put your hands up. Or you can even type in the chat and then I'll be able to pick your name if you have not seen where to put your hands. Okay, can I have Carol? Carol, Uganda.
Thank you very much. I hope it's okay to have another Ugandan speak before the other countries.
Yeah, it's okay. I mean,
I want to share my experience from the Ugandan context on how we assess wetland degradation. I work with Ministry of Water and Environment, Wetlands Department. We do undertake wetland inventory because that forms the basis for us to assess the state of our wetland. We regularly undertake mapping of wetlands. Right from 1994, we have been able to map our wetlands, and in the consecutive years, we've been able to map and determine the state and also look at the trends as well. Working with the National Forestry Authority, which does the land use land cover mapping in the country. Together with that, we do undertake regular monitoring on ground so that we're able to establish what actually happens and what is happening. In the process of undertaking wetland management planning, we also have several stages that we go through, and one of them is to assess the state of the wetland. So all those approaches are used together to look at how the wetlands are faring in the country. So in terms of utilization of Earth observation data, I think it's applied across all those stages in monitoring, in mapping, in inventory. So that would be my submission from the time.
Okay, thank you, Carol, for your input. Thank you so much. Anyone else? Okay, from the side of my team, Brian Maccabee.
Yes, hello Paul, can you hear me?
Yes, I can hear you.
Yeah, so yeah, I raised the question in the chat. In my view, what I think is that I mean, when it comes to wetland vulnerability, I think it may be in the policy whereby with now the increased population pressure that we have, compared to the earlier days whereby use of wetlands was completely not tolerated. But now you find that now there are some activities that are being allowed with permits, for example, to operate in the wetlands. So that's why now you are seeing, for example, rice growing taking off in wetlands, Irish growing in southwestern Uganda, and then also around Masaka having now sand mining. And in my view, this question goes to the experts here in wetland management, how well do they assess these activities to see that they do not have an impact on wetlands? So that if these activities are accepted, but they are having an impact and people actually have permits to carry out these activities. So in my view, if that's not reversed really to zero tolerance, then I think the vulnerability will still remain very high to wetland destruction. So that's my submission, Paul. Thank you.
Thank you, Brian. Thank you, Brian. I also know you're a GIS expert. Any input in terms of the use of Earth observation data, maybe somewhere? Okay, Brian is off.
Obviously, for me, my input in it is that when you are monitoring wetlands and you use only GIS data, there are some things, for example, you cannot easily model, and so actually when you combine them, you have a good vulnerability map or index developed than when you actually do only the GIS. Why do I say this? You'll find that with remote sensing, the subjectivity is a bit reduced because you are basically monitoring what you see. And if the resolution is right, the spectral resolution is also okay, high enough, you find that actually when it comes to monitoring, for example, the, 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 the continuous loss of a wetland, for example, you'll find that you measure the speeds reliably and accurately, and then understanding, for example, issues like how much per earn, their wealth, the land cover used in terms of commercial, how well they are, for example, livelihoods. Then there you leave it to GIS. So in my view, these tools are powerful at particular factors, and the experts in wetlands have to use both for particular factors, then you combine to come up with an overall. Otherwise, if you leave out one, you cannot completely model, for example, using only GIS, and you can't completely model the vulnerability using only remote sensing. So, Paul, that's my submission.
Thank you so much, Brian. That's awesome. Okay. David, I'm going to come back to you. I think your question is in the next discussion slide.
Okay.
Okay, I hope people have exhausted. Wanyama, seem like you have another input.
I also want to share something small. Yes, so recent I did a study in Kampala. I was doing the spatial temporal dynamics of waters in Kampala. But what I discovered that the wetlands that are so close to the roads are more vulnerable to degradation. I don't know whether you have noticed it over time. We discovered that wetlands that are far away from the road networks, they are less vulnerable. And
Yes.
hello, yes. And I also agree with Mr. Brian that when you are doing this thing, you need just a combination of many factors. But if you have to use only one factor, you may not be able to get good results. You need to have a variety of them and put them together and have concrete and accurate results. Thank you very much.
Thank you, Wanyama-san. Also, my input on issues of the roads. You see, I did also some analysis at some point to look at the level of density distribution of shea tree in the northern part of the country. And I was very much thrilled by the fact that one district, which is Abim, had a very high distribution of this tree. But later, when I went on ground, I realized that accessibility was a challenge. So the roads are not there, the place is rocky. So sometimes, even when they were doing the plans of opening the northern bypass, this is what was a big discussion, that the moment we create a road within this, along the wetland in the Lubiji, this would really expose the wetland to the different activities that we see now. So it is very true that access is one of the cause of making the wetland vulnerable. And in our analysis, you'll actually see tomorrow that when, in terms of using the aspects of the built-up areas, which the roads are also included, you'll see that it will take a bigger percentage or the bigger weight in making a wetland vulnerable. So in other words, if a wetland is neighbored or is crossed by a road, the level of vulnerability of that wetland will be high. So it is very true that that is also one of the things we included in our analysis. So quickly, Alan, in case you want to say something, Alan is one of my team members. I have Joseph Asimwe. So people from other countries, please try to contribute. I'll give a chance to Joseph Asimwe also.
Yes, thank you very much. I am Joseph Asimwe from Uganda. I like the question that Brian raised in regarding the activities that have been permitted in wetlands, and specifically some of the sensitive wetlands, as he clearly highlighted. I would also like to add by inquiring the justification of why a wetland use permit should be acquired for activities that have already been permitted to take place in these wetlands. For example, if a road goes through a wetland and the EIA has been made and it has been approved, why would the same project undertake or apply for a wetland use permit? What would then be the role of this wetland permit? Thank you.
Wow. Alan, before you come, I want to give, okay, this is not where we should be asking very technical questions, especially regarding to management of wetlands and all that. But in case any representative or anybody here who can be able to give an answer, can be able to share.
Thank you, Thomas, and the discourse taking place. I just wanted to, in a way, provide a rejoinder, or not really a response, because I'm not in authority to speak for the approving authority. But I believe that why you need to obtain a wetland user permit is because the activity that has been permitted is regulated. So the permit, in essence, provides the terms and conditions of what you can do, how you can do it, and how to do it, and of course mitigation measures and things like restoration and providing for biodiversity that could exist. It's also, of course, drawing from the course that different wetlands are at different levels in terms of vulnerability and sort of ratings. One wetland might be more sensitive than another wetland. So I think the permitting system is still sort of like a carrot and stick. So you have to always go back, and we cannot just give a general approval and say, okay, since this is permitted, please proceed. So I think it's what would say a case by case basis, and of course these activities that are permitted are still regulated. So I believe that's why you still need to obtain really a permit or a certificate to allow you to do whatever activity, and especially if it's a road. And of course, yes, this is the same thing, what will be done. But a good example is what UNRA has done with the Entebbe Express Highway in Uganda, the road that links Kampala to Entebbe to the airport. There's a 2.5 kilometer stretch I think quite expensive technology was used or applied, and I think it also came at a higher cost. But basically, the road is suspended over the wetland, and so the integrity of the wetland is not undermined. So it continues to function, its connectivity and its functions. At the same time, the road was able to fly over. But if we were to use the approach of, every problem like a carpenter needs a hammer, probably would have backfilled that area, put some culverts, and, would be able to have the road over. So I believe this is why we still need this kind of mechanism in place. I hope I've help to put some things into context and perspective. Thank you.
Thank you, Henry. So Alan, come through.
Good afternoon, everybody. I would like just to respond to some of the comments regarding the weights and the factors I saw in the chat. Well, one thing that we have to know about this vulnerability assessment, because it's based on the multivariate analysis approach, we have to know that the factors, whenever we do a vulnerability assessment using this kind of methodology, we are actually generating scenarios. So depending on what you think would increase the vulnerability, that's what you basically give the highest weight, then you generate a scenario. And these scenarios help us do the planning. So for example, you could say, what if maybe we look at the state of the wetland? What if it is improved? What would happen? So basically you try to assign weight based on the scenarios that maybe you want to plan for or that you want to achieve in future as far as reducing vulnerability is concerned. Another thing is that it's not very easy for us to be able to get all the factors that exist in this universe about wetland vulnerability. The thing is that you can only get the factors that you know as an expert, and those ones from literature, and maybe the ones that you get from the community. That means that we always have to find out what other factors affect the vulnerability of the wetland. So in other words, at the end of it all, when you have this vulnerability assessment, it gives you at least a picture of what the vulnerability is, rather than you not having it at all, because then you will not have a data-driven kind of approach to feed into your decisions. So with this kind of methodology, we can be able to feed into our decisions using some kind of evidence, and then we're able to produce some kind of scenarios. So that's basically what I wanted to contribute. Back to Thomas.
Thank you so much, Alan, for that input. So next, our time is gone, but we need to have a quick discussion. I see a lot of questions coming through the chat. So the question that we are going to have in a Q&A is for you to give, for the training team to give you an input for your current project on assessing degradation of wetlands or vulnerability. But ask those questions. I wait for those questions to come through. You just put up your hand and then we'll pick you. And you ask us. Yesterday, somebody talked about having a project, an ongoing project, and they needed to be helped. So probably at this point, we can be able also to give you some hints. And through these hints, we can be able to learn from each other as we go. Amer Shrif is asking, what kind of technology would we need to create wetland in an area with high degradation? I don't know what you mean by this question. Maybe you're trying to ask, how do we go through the restoration of a degraded wetland? So I'm just going to pose that question maybe to anybody in the participant, to, in case they have done a restoration activity, what kind of technology or activities could best be done to curb this issue. I'm just going to tell my IT person to allow people to unmute themselves at free will so that we can be able, anybody can come through and answer some of these questions. So for the wetland experts who are doing something on restoration, what answer can you give Amar, who is asking what kind of technology would we need to create or to restore a wetland that has been highly degraded? Just unmute yourself and then you can be able to respond. Okay. Maybe somebody will respond in the chat, I don't know. Okay, David, I'm coming to you next. David Ebong, please go ahead.
Thank you very much. I am from Uganda and I come from Apache district where is the highest prevalence of malaria and mosquitoes in the whole world because of the significance of the wetlands we have to the extent that our people sometimes feel the wetland is a curse, but I think there is still more benefits we maximize from it. And these are wetlands that are completely intact. They are not degraded. That's the beauty of it. The challenge is how we enrich it with sustainable conservation initiatives. I'm not a scientist, but I follow scientists critically so that I have a rough idea. And there's been initiatives of introducing bamboo for livelihood options and conservation of the wetland resources. So the stakeholders are looking for ways where we maximize conservation, but also profile areas where it could bring high returns for increasing livelihood options. So I would like to benefit from expert opinion here on how even the private sector led role could be utilized for maximizing benefits of these resources. Thank you.
Thank you so much, David. I would like to give Enoch Kaluba an opportunity, then we shall go to Wanyama, then Esther. Enoch, unmute yourself.
Thank you, Thomas, and members. I'm not a wetlands expert, but I have a question more related to GIS and remote sensing. The framework or methodology that you're proposing for assessing the vulnerability to these wetlands. In many developing countries, Uganda inclusive, there's a big challenge of existence of spatial data sets. And yet a lot of this, if we are to use GIS, needs, like Alan said, multi-criteria decision analysis needs, you're considering many factors, and these are many data sets that we have to use. How does this framework or methodology that you propose rate in terms of for a situation where a country maybe does not have so many existing spatial data sets, against having maybe to produce new data sets and going to the field and things like that. Maybe in cases where there's limited data sets, could we still have an assessment that can give us reliable results? Then also in line with that, what would you advise if you have, say, spatial data sets that you have to use for analysis, and maybe they're at national scale, but you're doing it for a small area? How would you maneuver such a situation? Thank you. Those are my questions.
Okay. Thank you so much, Enoch. I'm going to give a chance to Alan just to respond on the methodology which may be used that doesn't really require a lot of data sets. Is there any other option? Alan, you're free to unmute yourself. Okay, as Alan comes through, I'm just going to respond. There are different methodologies that can be used in assessing the vulnerability of wetlands. During this process of generating this adopted methodology, we looked at three types of methodologies. One was the community-based approach of assessing vulnerability of wetlands. So here you basically generate questionnaires, and then you go to the communities where this wetland is, and then you ask them the different questions relating to the vulnerability of the wetland. And then you analyze your data, and then that's it. Two, also we looked at the probabilities methodology for assessing the level of vulnerability of wetlands. And all these methodologies had challenges in the fact that we rated them actually at some point, and then found out that the different components that are very vital are actually not included in any of them. The third one that we looked at was based on, just skipping through my mind. Alan could help me much. Alan, come through. Alan, you can unmute yourself.
Okay. During the vulnerability assessment, we had various methods to consider, and we saw that maybe we could choose, for example, the statistical method. But then we found out that this method will require you to have a lot of data. You must have the data, and the results are always dependent on the data. So if the data is bad, the result will be bad. And then the stakeholder is also locked out with the statistical method. And then we also thought that maybe the statistical method basically works at all scales. All scales can work at the regional scale, at the local scale, and maybe at a continental scale. And then we thought that maybe we could get also one that can include maybe community. And then we thought about the community vulnerability prioritization and analysis. But the problem with that is that it works basically best at a local scale. And then also, if you try to have GIS analysis for that kind of methodology, you need a lot of data. So we then thought to get some methodology that can be able to incorporate all these kinds of aspects, the benefits of all these aspects. You have the stakeholder included, and then you also have the data-driven kind of approach included. And that's how we ended with a multi-area evaluation that includes both the participants, rather the stakeholders, as well as also the expert knowledge. Now, when we talk about Earth observation data is it can actually be gotten for smaller areas, areas that are small. That's basically the advantage for using Earth observation data. Like we already told you, the proxies that we use for these indicators will vary depending on the availability. So if you go to a place and you find that maybe drought can be captured with the standard precipitation index, then so be it. Maybe it could be NDVI that captures it in another scenario. So that's how basically we play around with the existence of data. So we also know that you not having an analysis, of course, you're going to make your decision maybe not based on, you miss that advantage of using the data. So we think that maybe with whatever little data that you have, you can at least have a smaller picture. You can have a picture of what the vulnerability is. And so basically accommodates that kind of thing, as we shall show you in future. And these factors can always be gotten as time goes on, depending on the availability of data. So that's basically the sustainability bit of it. You can always get more indicators, more factors, depending on how your knowledge increases, depending on how basically your resources in terms of the data, and then you also be able to do a vulnerability analysis. So thank you very much, Thomas.
Thank you, Alan. So quickly, what I want to add on to Alan is the methodology that was finally adopted, looking at the different challenges that each of it was having, was a combination of the later tomorrow we will see that at some point we were doing probabilistic sort of input, whereby we are generating the kind of weights based on the probabilities method within the GIS software. But also we saw that there is the importance of involving the stakeholders or the communities. So the aspect of the community-based method of assessing the vulnerability was also integrated. And then the aspects of the indices, looking at vulnerability index method, was also integrated at the end of the final methodology. So the beauty of using the Earth observation data and why we're trying to embrace it is that sometimes you might be carrying out assessment or running analysis of the vulnerability of a wetland in a very hard to reach areas. You're having challenges even picking the quality of the water. For example, if you're doing in the open water wetlands, it is very difficult for you sometimes to pick, and sometimes also the equipments are very expensive. Look at equipments for measuring maybe the different water quality parameters. You may not be able to afford them. But using the satellite data, we now have this, some of the data sets are available that measure the chlorophyll level and also the turbidity water levels of a wetland or a water body of a wetland. So you'll see that you'll try to embrace this aspect of the Earth observation whereby you're acquiring the data that has already been collected by maybe a funder, and you're actually utilizing, and also for a hard to reach areas. So it's not that after doing the analysis you are 100% correct with the outputs. Of course, you'll have to first go and do the validation, but also it will give you a quick overview of exactly what is going on in that wetland. Wanyama, Johan has been up for long. I hope you can still remember the question you are going to respond to.
Thank you very much. There's one of the person who asked that how can you restore a wetland that has been highly degraded?
Yes,
Was it the question? Hello? Yes, and I just want to give my experience to what happens on the ground. You find that there are areas that indeed they are highly degraded. I can give an example, areas to do with Rogogo and some parts of Kampala. that are highly degraded. And you find that if you are to restore such areas, the cost of restoration itself is really very, very abnormal. And what the government decided is to declare some of such areas as vanquished, that we cannot, the cost of recovery or restoring them is really so much that they have been declared vanquished. So the type, if we are to restore wetlands, you also have to look at the type of the degradation itself. If a wetland has been degraded through dumping of maram, then that one, from experience, is more expensive to restore. But where the type of degradation is cultivation, is maybe planting of eucalyptus, that one is easier. And we have done it so much, especially in areas in eastern Uganda and any other areas. For example, if you are to go to Palisa, there is a wetland called Remoto, which people had invaded through cultivation of rice. So when we went there, we discovered that the type of degradation is cultivation. So we chased away the people, we broke the drainage channels, and up to now, when you talk, as we talk now, the wetland has regained. We have also done it in Masaka, that Nakaiba wetland, some 8 to 5 years ago. It had been degraded, but we just chased away people and did some replanting of some wetland species. As per now, it has regenerated. On Masaka Road, Busega, if you normally use that area, that road there on the right side, people had invaded that area. They had put up a church. So when we went there, we put those things down, and wetland has so far regenerated. So basically, the type of degradation, if you are to restore wetland, you need to first look at the level or the type of degradation. And in most cases, where you see maram, dumping maram, one tipper of maram, or removing one tip of maram is 5 times more expensive than the cost you used to dump. So that one has been a challenge to us, and that's why most areas, most degraders in Kampala use that as that is the most used type of degradation in Kampala here. Thank you.
That soil erosion data is very key to see which areas are vulnerable to the soil erosion when it rains. So the most important thing there will be for you to include the data sets for the soil erosion or eroded surface and so forth. That will enable you to check the level of vulnerability of your agriculture within the hillsides. Thank you so much. Time has gone, and I appreciate everyone who has given the input, including those who have given their inputs in the chat. I've seen the chat was very busy. This is very, very encouraging, and you much appreciated. I need to re-echo that tomorrow we are going to have a hands-on. So there are a number of housekeeping things that you will need to have tomorrow in your laptop. One is you need to have a QGIS software. So a QGIS software version 3.16 would be the best. I think it's a long-term version that is very stable. So if you have that version, that is good. But if you don't have, try your best tomorrow to download and install it. Then we'll go through the process of acquiring data from different sources, basically the Earth observation datasets. And then we'll go through the process of preparing these datasets or processing them within the QGIS environment and get it ready to generate the final output